Once we have the coefficients, the rest is pretty standard stuff. It's easy. So let's first color code unit cost, intercept and slope. Okay, and we want linear model here. So pricing model, price is the changing cell for us. Okay, so the demand is intercept plus slope times price. So that's our demand. So profit then is, okay, let's give some names here, unit cost, and then these three. Okay, then profit is price minus unit cost times demand, and that's what we want to maximize. That's our objective cell. So now we are ready to run the solver. Okay, go to solver. We want profit to be maximized, and we want to change the price. Okay, and we can add a constraint which says price must be greater than or equal to unit cost. So we want to not make a loss, in other words. Okay, now you can go to options, GRG nonlinear, and if you uncheck require bounds on variables and use multi-start, then you don't have to really give the upper and the lower bounds. Click OK and solve, and we get the best price at which you will have the converged in probability to a global solution. Now we can set up a data table to verify. Okay, so we can set up different prices. Okay, let's assume we need to leave the first row blank. So let's assume that we want to go from $55 in increments of 5 all the way to 115. Okay, and we want the profit to be tabulated. Okay, so now this is a one-dimensional table. So highlight this whole area, and you go to data table, and column is the input, and you want these prices to go into the price cell. So click OK, and when you see all of these as 9,000, that's because the calculation is set to automatic except for data table. So if you go to options, okay, formulas, and you see calculation options is set to automatic except for data tables. So data table will not get automatically recalculated. So if you select this, then it will. So let's go ahead and select that, and then it will get automatically recalculated. But if you want to leave it like automatic except for data table, then you have to press F9. If you press the F9 key, that will force an automatic recalculation. So if you have set the calculation option to automatic, then data table will automatically recalculate. But if you have selected the option for all cells except data table for automatic computation, then you have to press the F9 key. Okay, now let's plot the price and profit. Okay, with the profit on the y-axis, price on the x-axis. So since it is the y-axis values are on the right hand side of the data here, and we can highlight the two columns, and go to scatter plot. We'll select that one. Okay, we don't need the legend. Okay, let's put some titles. Profit versus price for linear demand. Okay. And vertical axis is profit. Horizontal axis is price per unit. And let's format this axis, number format, to currency with 0 decimal places. So I'll put it there. And we can even change the x-axis to start from, say, 55. Okay, so because that's the smallest price we are considering. And you can see that the maximum profit is achieved somewhere around here, which is what we got, $80, about here. Okay, now constant elasticity model, again, unit cost is an input, and these are the constants that we found from the demand function. We have the pricing model, and price is our changing cell. Okay. Now demand is going to be like that. B sub 0 or constant times price to the power. So that's shift 6 of that. So that will give us the demand. And since price is 0, you get a division by 0 error. So what you have to do is to put a number there, any number, just some starting number. Okay. So otherwise solver will not work. So you have to make sure that there is no divide by 0 error as a starting point. So now profit, okay, let's give a name for these cells. So profit is price minus cost times demand. Now that's what we want to maximize. So that's our changing cell. So let's go ahead and run solver. Okay, remember, make sure that the demand is not a divide by 0 error. The demand cell does not have divide by 0 error. So price, and once again we can add price is greater than or equal to unit cost. So let's okay that. Now let's go back in, make sure that under GRG nonlinear multi-start is checked, and we don't want any bounds. Okay, now click OK and solve. So solver converged in probability to a global solution. Okay, so now if we have constant elasticity, then the best price is $93.31, and that will give you a profit of $93.26. So if it is linear, then $80 is the best price, and if you have constant elasticity, then $93.31 is the best price. Let's plot this again. So let's go back to the linear case, and we'll copy these prices. Need to leave the first row empty because we need to specify the profit there. So now we'll run data table. So make sure that you highlight this range and do a data table, and this is the column input cell price. Click OK. Now since we already set automatic for recalculation, then it comes up with the actual number. So let's change the format here. We want currency and we don't want decimal places, and let's plot this. Okay, so let's change this to 50 to 115 and the number format to currency with 0 decimal places. That's for the price, and here's the profit. Okay, let's give titles. Chart title is profit versus price. Horizontal axis is price per unit. Vertical axis is profit in dollars. And you see there is a slight after this point. See, the curve bends down. So the maximum is achieved around here, which is $93.31. So in this example, we had only 2 points and we had to come up with the functions. So if you have more points, and you'll follow the same logic and use all of the points to plot and get your coefficients. And we only looked at linear and constant elasticity models. Okay, I misspelled elasticity here. And we can have other functions, other nonlinear functions as well.